Good morning, everyone. Today, I, C.R. Deepak Kumar, will talk about my second question of the Kearney assessment. My roll number is 1833009. Now, I'll open my Python notebook. So, this model is known as the heart failure early detection model. So, basically, this model will be able to detect patients who are at a risk of heart failure at an earlier stage. So first I have imported all the libraries needed for my predictive model. So you can see here it's Matplotlib, Pandas, Seaborn, Imbalance Learn, ML Extend, Keras, TensorFlow, and Vexstack. I have read the data set using Pandas, and here this shows the first five rows of the data set. Now I want to check if there are any missing values present in the data set, and as you can see, no variable has any missing observations, so it shows me zeros. So I can move ahead with the analysis. And now I wanted to check the format for every variable present in the data set. So dtype shows me the format of every variable, and it's all in float or integer format. So I can go ahead with the analysis because none of them are in the categorical format. All are in the numerical format. So I'm going ahead with the analysis. So observations present in the target variable, as you can see here, 0 is negative and 1 is positive. So negative means people who are not at a risk of heart failure, and 1 is the positive, which means people who are at a risk of heart failure. So people who are not at risk are significantly more than people who are at risk. So therefore, we can say that it is an imbalanced data set. So I have to balance the data set. So now before balancing the data set, I have to do some pre-processing methods. So first I have to separate the data set into independent and dependent variables. So dependent means target variable. So here is my x and y. My x is the independent variable while y is my death event, which is the target variable. And now I pre-process the independent variable so as to get all the training or the independent variables in a similar measure so that my machine learning models can predict the uh, predict the predict with the parameters accurately. And then I split the data set into training and test data set using train test split, and this is used based mainly for the evaluation methods after I make the prediction models to verify whether it's accurate or not. I have now defined the XGB classifier from the XGBoost library, which will be used for predicting the for the prediction of the model. So now I'm going to balance the data set. So I'm only going to balance the training data set because my test data set is going to be the real world analysis. So I will not touch the testing data set while I will train my training data set to be an balanced one so that my model, my prediction model is not biased. So I've done the oversampling method to balance my data set. So as you can see from the result, before the oversampling, it was 83 positive or 156 negative, and after oversampling, it was equal, so 156 to 156. Now I've defined a random search algorithm, which will be used to find the best estimator for random forest algorithm. So after defining random search, I have defined the parameters for random forest algorithm, and I've given the ranges for every parameter. So in this range, the random search will search for the best parameters with the best values to give the best accuracy prediction model. Now I've defined the random forest algorithm as a CLF. So first I will do a cost effective random forest algorithm, which means I will not be using the oversampled training dataset or the balanced dataset. I will be using the imbalanced training dataset because random forest is not affected by the imbalance present in the dataset, and it can still give a accurate prediction. So therefore I'm using this, and this is what we call a cost effective random forest algorithm. So I've done the random forest to find the best prediction model through random forest, and the final prediction score is 93%, which is quite accurate. So now I've made the confusion matrix to analyze my result. So over here you can see on the y-axis 0 and 1 is present, which is the actual values, while 0 and 1 present here is the predicted values. So as you can see, true negative. So true negative is 46, so which is quite high. And over here it shows a false positive, which means a person who is not at risk of heart disease was shown that he was at risk. So basically, the any hospital using this algorithm might waste some money for for the treatment of this patient. So now moving on to the false negatives. So false negative is actually much more worse than a false positive in this scenario, because false negative means that he was actually at risk of heart failure, but our model gave that he was not at risk. So the patient could die if this algorithm is used in the in the hospital. Therefore, to improve on this and to reduce the false negative, I'm going to use XGBoost and AdaBoost to improve on this false negative number and decrease it. So now moving on, this is the precision recall and the F1 score of the random forest cost sensitive algorithm. So uh, as you can see, the precision is quite high because the true negative and the false positive is is showing a high accuracy, but my recall is quite low because I have more false negatives compared to the overall actual positive values. Therefore, my recall is smaller. I mean, it's less accurate compared to my precision score. And as I said earlier, my main analysis point is the confusion matrix, because I want to reduce the false negative value so that there is no loss of life. And if my false positive increases, the treatment on the patient will happen, and eventually he will be found to be not at risk. So the patient or the hospital may lose money, but at least the life will not be the life will be saved. Now moving on. So now I have I have defined the XGBoost classifier parameters. So column sample by tree, n estimators and max depth, and I've given the range for each of them. So I'm going to use grid search, which I have defined here for XGB classifier, and I've defined the grid search for my XGB classifier. Again, I've given the balanced accuracy as my scoring, but now I'm going to train my XGB classifier with the balanced dataset, because XGB classifier is not like random forest classifier. It will be affected by the imbalanced dataset. Therefore, I'm training it with the balanced dataset so as not to have a bias. So now moving on, after the grid search is done, I found this to be the highest or the best estimator for my XGB classifier, and the score from this which I got was 86.5, which is obviously lesser than the cost sensitive random forest algorithm. I will not do a confusion matrix for this because I'm gonna be using stacking methods for the accuracy for the analysis. So right now I'm just finding the best estimators for XGBoost, AdaBoost, and Random Forest. So now this is a non-sensitive, non-cost sensitive random forest algorithm, which I've again done using random search. But over here I've trained the dataset using the balanced training dataset, and I got the best score to be 86.8, which is again lesser than the cost sensitive random forest score. So now to improve on this, I have used ML extent stacking method. So I have not used AdaBoost for this method, but I have only used XGB classifier and random forest for my stacking method. So first I'll be stacking the random forest best estimator and the grid MSE best estimator, and after the predictions are done, I will be then using the random forest as my final model to train the dataset from the prediction it got from the first model classifiers, which is both XGB and random boost, because over here I thought random forest was a superior model compared to XGBoost. So I've used random forest as my final model to do the prediction on the first model classifiers. So as you can see, I have trained it on the balanced training set, and it has calculated the best algorithm. And now I've done the overfitting check, and I found that the training set is 100%, but my test testing accuracy is 85. So I think there is overfitting taking place. So therefore now I'm moving on to another method of stacking, which is vex stack, which I'll show you uh, um, afterwards. So first I've defined AdaBoost classifier, and then I've defined the AdaBoost parameters, and then I've done grid search on the AdaBoost algorithm to find the best n estimators, and it showed me that the best n estimators was 52. So and the score was again 82. So the score right now does not matter for me because I'll be using AdaBoost in my stacking in my vex stack method of stacking. So now to give the best AdaBoost estimator a boost, or to make it much more stronger, I've made the base estimator of my AdaBoost classifier as random forest best estimator. So basically, this random forest was trained on the balanced training dataset, and AdaBoost will then boost the random forest estimator to give a much more better prediction. So right now, the most superior model which I have, or the best estimator which I have till now, is the AdaBoost classifier compared to the other two classifiers. So I'm gonna use VecStack method of stacking. So in my VecStack method of stacking, I can use many more parameters to improve on my score. So first, I have trained all the three classifiers. So AdaBoost, Random Forest, and the XGB classifier. So over here, I've done the stacking method and defined the stack models, the balanced independent and dependent variables, and the testing set. And I've also used the mode as out of the bag prediction bagging score. So basically, again, it will improve on the model prediction. And I've also used the cross validation uh, for this stacking method so as to avoid overstacking taking place during the prediction process. And after this, the first model predicts, my, the final model, which is my AdaBoost model, will then fit on the trained predictions which it got from the first model, and then predict from that. So that way my first model has three classifiers, and then from the three classifiers it gives me another new prediction classifier or a prediction dataset for the three models, and then my final model will then use this new prediction result with the training target, which is the y train balance set, which is shown here, and then it will then improve on the already predicted uh, data set. So that way my score and my accuracy will increase using this method. So as you can see, there are three models. So AdaBoost goes through four-fold because I've given n folds for cross validation. So it goes through four folds and gives me a accuracy of 87.5. Similarly, for random first it's 86.2, and for XGBoost it's showing me 86.8. And after the three stacking models are done predicting, AdaBoost takes the result from the three models and then predicts its own model set, and from that the score which I have received is 90%, which is the highest till now. So therefore, I think it has come close to the cost sensitive random forest algorithm. And now I'm going to analyze this stacking score. So the confusion matrix here is uh, over here it's true negative, which is 42, and the false positive is 5, so it has increased. While the good part or the improved, to show that this model has improved, you can compare it with the false negative, because as you can see here, so basically actually he is a positive patient, but so as you can see I have received the now to analyze the stack prediction. So as you can see here, the true negative is 42 and the false positive is 5. So false positive has increased compared to the cost sensitive random forest algorithm. But now if you move on to the false negative, now that has decreased. It is now only 1. So now this shows that this model is good at predicting so now to predict the or now to analyze the stack prediction model using the vex stack. So as you can see, I made the confusion matrix here. So you can see here it's true negative. So true negative is 42, while the false positive has increased compared to the cost sensitive uh, random forest algorithm. So now it is 5. But now if you check the false negative, which means actually he is positive, but I have predicted it to be negative, is only 1. So false positive, false negative is only 1. So therefore this is a great improvement from the cost sensitive random forest algorithm, and the true negative has subsequently increased to 12. So now to compare the accuracy, precision, recall and the F1 score. So as you can see, the precision has decreased because I have a increased amount of false positive compared to the cost sensitive random forest. So it's only 70%. But now my recall has significantly increased to 92% compared to 76% of the 76% of the cost sensitive random forest method. So I can conclude that this VecStack model saves lives, but could be costly to the hospital. But my cost sensitive algorithm is less likely to save lives, but it will most definitely save money for the hospital. So this is like a so the stacking method over here which I've done is a life saving model compared to the cost sensitive random forest method. So if if I have to advertise or promote any model, it will be the stacking method which I have used here. So now I have done the oversampling method for balancing the data set. So now I'll move on to the undersampling. So undersampling is the same thing, but as undersampling and oversampling both are used to balance the data set. So again, you can see the testing data set is 83 and 156. So now when you balance it using the undersampling, it becomes 83 and 83. So that is the only difference. Oversampling, it would have become 156, 156. But with undersampling, it will be 83 and 83. So again, I have done with the undersampling, the already trained variables. I have trained it with the undersampling method to use it. So over here you can see that my undersampling method, this is with the random forest, and this is with the XGBoost. And then now this is the AdaBoost classifier. So again I've done the vex stacking method because I've seen that this is the best prediction model. Now moving on, it's only giving me 83%. So I have not done any further analysis with the undersampling method and stayed with the oversampling method. So oversampling method is giving me a much more better predictive model. So I'm going to stick to that, and I'm going to drop the undersampling method. So as you can see here, my stacking method is the best life-saving model. While my random forest is a cost sensitive, which means it will be saving money, but the lives at risk, the probability of lives being at risk is higher in the cost sensitive algorithm compared to my stacking algorithm. So that is all. Thank you.